develop a horizontal projectile model. And on page 265, you're going to draw this line. And every dark line is 10. And we're going to go all the way to 120. So go ahead and fill this out. Okay, I'm going to go 130 or 125 just to be an overachiever. This is our Vx in meters per second. So this is our velocity, because now, if you remember, horizontally launched projectiles, they have 2 dimensions. So we're going to have the velocity in the x dimension, and we're going to track that. And then we're going to have our velocity in the y dimension. So now I'm going to go down. This is the Vy in meters per second. I'm going to go down by 10.
220?
220, yeah. Okay, now, what we learned was one thing that we learned is Vx in a horizontally launched projectile is equal to the Vi. And Vx does not change. So with that rule, Vx not changing, well, if the Vx is 20 here, if the initial velocity of the cannonball is 20 here, what would every second, so this is every second, what would the, so it's going 20 meters per second, so what would, at 10 seconds, what would the velocity be, what would the velocity be at 20, what would it be at 30, so on and so forth.
Going 20 meters per second. At 10 seconds, would it be 200 meters?
What? 200 meters? How about we make it 10 meters per second? Does that make it easier? Okay. So this is 10 meters per second here. And at this point, what's it going to be if Vx doesn't change? What's the Vx going to be here? The same. So, with your different color, you need to draw how long are you going to make your Vx. Are you going to make it 1 box long? Or are you going to make it 2 boxes long? It's your choice. But you've got to be consistent. So that's our Vx. So the moral of the story here is Vx what? Vx doesn't change. Okay, Vy does. Because that's what we were calculating for today for homework. We're calculating the Vy. So now using Vy does change. Why does Vy change? Because of what? Gravity. Okay? So we have to figure out what is our Vy, and we're going to change colors. What is our Vy at all these different points? Okay, so we might want to go down here and write 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, 120. What is our Vy at these times going to be? So this is time. Okay. What is our Vy going to be?
What
So
does
we
that
have
first thing say next to the...
this right here.
No. Next to the left of the Vy you just wrote, what is that?
That's a scribble.
Oh, okay.
Because this is time.
Okay.
Okay? So I have to calculate this. So what equation could we use to calculate this? Vy, your final velocity, is equal to 1/2 gt squared. So using this equation, here's your time. Put your time in there and write down what your Vy is. Put your time in there and write down what your Vy is. Can you handle that? Can you do that?
Why are we using that equation?
Great question, Charlie. I will answer that in a second.
Or,
That's the toil I'm in. Do I teach you the equations first and you not understand them? Or do I draw the picture and then the equations will make sense? So it's kind of a dilemma. So you're going to have to trust me on this one.
Did you get negative 490 for the first
Yes, you're going to get negatives. Negative what?
490.
Yes.
Okay. I just want to make sure.
what are we trying to find here? The time?
No, the time is right here.
Oh, that's time.
Yeah, that's what this T is.
Alright.
And then we're trying to find Vy. So you're going to take the 10 and you're going to put it in there and you're going to find Vy and you're going to write it right there. So you're going to find all of these right now.
What do we do about the,
What?
what do we do about the sound?
Do what about what?
The G.
The V,
The G.
the
It's
G,
negative 9.
negative 9.8. Okay, now we need to graph it. You ready? Do you have your numbers? So this was, what did you say the first one was? 4 point what?
Negative 490.
What?
Negative 490.
490?
Yeah.
Really?
Yep.
Well, I got you.
Because half of negative 9.8 is negative 4.9 times 10 squared. So it's negative 4.9 times 100.
Okay. Oh boy. Our graph isn't going to work. Because we didn't, if we want to draw this arrow, we have it in tens. So we don't even have our scale to 490. So what did I explain to you now? Oh. Okay. All right. So you're going to get really mad at me. Change this to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So what we did is we accidentally put the distance in. I wrote the distance down. You should have, I did not write the time down. So I led to a string. I made a mistake. I'm sorry. So you're going to have to recalculate. So you should get 4.9 here. That's the real thing I'm looking for. So you should be able to take your numbers and divide by take all your answers and divide by 100. I'm sorry.
Yes, that would work.
Okay, so you can just move the decimal point and rewrite your numbers in the thing right next to them. You don't have to recalculate. You can just move the decimal point 2 places to the left. You can go from 490 to 4.9. Okay. Now are we ready to start graphing?
Almost. The numbers are still going to be too big though.
To her?
Yeah.
It worked on my graph when I did it. Okay, so here we go. So you're going to take this number, 4.9. You have your different color, right? So you're going to bring this down and go like this. So there's your BX. And then you're going to have your other color. And that's 4.9, which is roughly 5. And that's going to go down like this. And that's going to be a VY for the first point. What's 20? Well, what's 2? What you get for 2?
Negative 19.6.
Negative 19.6, so I'm going to round that to 20. So then my next one will look like this. So that's 10. Look at that. See what I'm doing? So then I'm going to bring the third one down. The 30. Alright, what are you noticing? Anything exciting? Well, what's the next one? 29.4?
3.
Yeah.
I got 44.
I got 44.
Negative 44. Negative 44 for what?
1.
Okay. So. Ooh, well, you're gonna not be able to do the whole thing, really, you're right. Okay, what'd you get for 40?
78.4.
Woo. The G. So, do you see a pattern yet? And what'd you get for 5?
122.5.
we'll have to stop there, huh? Okay. So you just developed a model for a horizontally launched projectile. So what do you notice about this? So what are some things that we can write, like rules? So we have rules here. Vx is equal to vi. If Vx doesn't change, Vy changes because of G. What else can we say when we look at this picture? Here's a better view of it. What else can we change? See, we have two components, right? And the components come together to be the what? The resultant. Do you see that? So let's zoom in on that and actually draw a picture of that. So this is the y component of the velocity, how much it's going down in the y direction. This is the x component of the velocity. So I actually have to pick this up and move it over to make the resultant. So if I did that, this one would be right here. Because remember, I can pick them up and move them wherever I want. I just can't change their direction and their magnitude. And here is our resultant velocity. So this is the resultant. So what can you say about the resultant velocity for each of these? There's the VR right there.
It's kind of like the hypotenuse.
It is the hypotenuse of a triangle. Our triangle is really skinny. Okay? Alright. So you can see this better. You see how I made that? There's our triangle. Here's our Vy and here's our Vx. See how I moved the Vy over? Okay, and we have the resultant. So you have three velocities. So the thing I'm trying to teach you is there are three velocities that you have to keep track of. Okay? There are three velocities that you have to keep track of. So let's make a list. There are three velocities. Let's list them. There's Vx, Vi, or Vy, and Vr. Okay? And with those velocities come some rules, right? So what are the rules for horizontally launched projectiles? There has to be a force. So what is the force that's causing them to move? This is a force diagram for a horizontally launched projectile.
Just gravity.
Just gravity, yeah. So mg is our force diagram for these. Okay? They are, they travel in a parabolic path. Due to the influence of gravity. Due to the gravitational field. There are no horizontal forces. Okay? The vertical acceleration is caused by gravity. Notice the vertical and horizontal motion are independent of each other. You see that? So your Vx Vx's and your Vy's are not connected at all. You can pluck out the Vx and talk about them. They are not dependent on each other. So you can mess around with the Vy all you want. Vx is always going to stay the same. Okay? Let's see. So you have to remember there are some equations that you have for these. So let's write down our horizontal projectile equations. Here they are. Nope, I lied. I thought I had them right here. I have a beautiful list of them. Give me a sec. Here they are. Okay, so here are your vertical, horizontal projectile equations. So you have Vy, F. So this is your final velocity in the y direction. And this is your acceleration in the y direction times your time. Then you have Vy, F. So notice what direction am I talking about?
The y direction.
The y direction.
Is that it's squared?
This is squared. So this is Vf squared. And I will answer Charlie's question in a second. So these are your Vy equations. Now we're going to have your Vx equations. That's your Vx equation, and then you have time.
Why on the second one do you have Vyf squared?
Okay, great question. So I'm going to write that down. Let's see here.
Should that be 2y or 2x divided by 2 for the t?
Let me write them. I think which was your equation, Bailey?
The last one you wrote, is
Yeah.
it supposed to be Vy divided by g, or is it supposed to be 2y divided by g or 2x divided by g?
2y.
Okay.
Because notice there's only one Vx equation.
Oh, and this is the time equation?
Yep. Okay, so now I'm going to explain all these. Where did I get these things from? I am not crazy.
Oh, third one down, is that Q or G?
Third one down.
Y equals half, and then
That's g for gravity.
Here you go. This is better.
G for g-force.
Okay, so this right here is gravity, and this would be negative 9.8 right here. That would be your acceleration in the y direction, which is negative 9.8. This is acceleration in the y direction, which is negative 9.8. So these are all talking about the big long arrows that we had. We just drew these. Okay, now where did I get these equations from? Vf equals Vi plus At. That's where I got this equation from. What is Vy initially? Vy at the very beginning of the path is always what? 0. So this right here goes to 0, and it's stuck with Vf plus At, and that's what this is. Does that make sense?
Yep.
Here we got VF squared equals VI squared plus 2 AY. My initial velocity in the y direction is 0, so that's gone, and that's why I would write that one right there. Y equals VIT plus 1/2 AT squared. That is this one right here, so that's going to go to 0. Okay. Okay, so you guys, your homework is to do 1 and 2 on page 264. Using your new equation, crying, not crying. Okay?
Have a nice day, Miss Ballback.
You too, bye-bye.